Heyo, what's up, everyone? Who's all here in the chat right now? We can start working on some R, seeing what we got going on. Stat Nation putting in those questions. What questions are there that you have right now? What questions are there that you have? Let's take a look. Michaela says, hello. Hey, Michaela, how are you doing? Let's throw out some U-Bot points. Hey, Rachel, what's up? Throw out some 50 points. Going crazy on these points these days. Oh, wow, wrong person in the chat. Where are we on the points? Let me hop over here. See if there's anything Michaela says. I saw Michaela's question. 2 seconds reloading. Can go over number 2 on the homework, you bet. Let's do this. And let's go back over to, got a toothache or gummache. 50 points. Let's go over number 2 on the assignment. Let's take a look. Getting it pulled up here as we go. Assignment number 9, indicator variables. Oh, you know one thing we didn't do today? Oh, no, we did do. Oh, wait. I lost my mind on this. I need to make one change to the assignment. So it's still the same sort of check regression. My brain blanked on it last night. Let's go take a look at the assignment. Here we go. Create the summary and interpret the following. Once again, don't use the variables I'm using right here. So I'm going to use, once again, do not use the variables I'm using. I don't want people using the exact same variables. I just use my classic height, weight models. So these models are like mine. You can't use them because I'm using them. Height not found, because we didn't do the data equals. So do not use my models right here. They're mine, not for you to be used. What's the key to what I'm doing right here? What is the key to what I'm doing? This also goes over a little bit of number 1 right here. I do need to make a small update to this assignment. Probably later on today, I'll send out the announcement about it because my brain blanked on the check regression. So what's the deal with this regression? What is the deal with this regression I've created right here? What is the deal? And you need to make sure yours follows this rule. What is the deal with this regression? What is the deal with it? What is going on with it? Visualizing it's probably going to help us see, which is a first part of the problem 2. If you visualize it, has a categorical X. Great job, Ivan, right there. Yep. And you can view it over here, the visualization behind us, and you can see here the value of the indicator variable. And just think about this. 2 people who are otherwise identical, but one is male and the other is female. Just think about this. If you have a friend, let's just not go stat BS 320 interpretation for a second here. You have a friend who is male, you have a friend who is female. They're the same weight. How much taller would you expect the male to be? You have a friend who is male, you have a friend who is female. They're the same weight. Like they both weigh 150. So let's go here to, I need to put the visualization back up. Visualize, model, AB line. That's the vertical line. Vertical equals 150. And then col equals purple. And then line width equals 2. There we go. So you have 2 friends. They both weigh 150. One is female. One is male. The expected difference between their height would be what? You expect the male to be what? They both weigh 150. Here's the prediction for the female. Here's the prediction for the male. 2 friends who are otherwise identical. They're the same weight. I have one friend who weighs 150. They're female. I have one friend who weighs 150. They're male. How tall would you expect them to be? Or the difference between their heights, I should say. And the difference between their heights is this coefficient right here. I wish I could make it so only it existed in this region. Probably weigh. Let me look up one thing real quick. I'm interested in the answer to this. AB line, vertical line with limits on horizontal. Ooh, is there a way to do this? Someone's asking. Segments. They're saying segments. Let me look at this code. Something I want to learn right here. Let's take a look. So what is this expected difference between these two individuals? You can see it here mathematically now. What is the expected difference between these two individuals? I want to see what this code does over here. What is this expected difference between these two individuals? Oh. Segments from x0 equals 2 to y0 equals 0, x1 equals 2, col equals red. Why is the x0 needed? Oh, because you have to put the xy coordinates. So could I add a segments on here? I'm going to see if I can do what I've always wanted to do right now. I'm going to try this and see if I can show the visualization the way I've always wanted to show it. We might get... That's not on the screen right now. Oh, those are like the arguments for segments. So this is the original x position. The original x position is going to be moving across the x-axis here. This doesn't make sense to me right now. 150, and then, but y should be, let's go y66, and y1 equals 70, and I don't think this is going to do what I want. Oh my gosh, I've destroyed it. Oh, we're getting something close. Look at that. Look at that. So you see right here, I just need to extend it down. And I can probably do a line width on it. I am getting almost the graphic I want. I'm very excited about this. I've always wanted to draw it this way as an example. Make it purple. We'll make line width. And I think this should exemplify exactly what we're talking about. Cool. Much better. We're getting there-ish. We need to lower the line and probably raise it up a little bit. So line needs to be lowered now to about 65. Actually, what I could do is I could, here we go, watch this. We're going to use the predict function here. We need a data frame with data.frame equals gender equals concatenate male and concatenate female. And we're putting in our 2x variables in here. And then we're going to put in weight equals concatenate 150, 150. And then we're going to do predict using our model on new data equals data frame. And here's the values. These values are the values we need to know exactly where to extend that line to, because that's the predicted amount for a male, and that's the predicted height for a female. Now let's extend our graphic, and let's extend up here a little bit. And what do you see? That's what I've been wanting to show. That difference right there is a difference of what between the two individuals, which is constant. This is the interpretation we're looking for. And you can see this mathematical difference just by subtracting the values we obtained. This distance right there on the screen behind me right there, that is a difference of about how much? That is a difference. And you can see the amounts we're getting and the numbers we already should know by looking at the output. That difference right here of negative 5.02, which is, we should do it positive because it is the indicator down here. Positive difference for males being taller. That difference right there that you see is that difference right there. Is this making sense, Michaela and Ivan, when you see how I calculate this? How I made predictions for a female and a male who both weigh 150. I predicted their heights. I used the predict function right here by using a new data frame. I stored my new data frame. This goes a little bit above and beyond for the assignment, but I'm making predictions for new individuals, a male who weighs 150, a female who weighs 150. I feed that through here through the predict function to make predictions to find out exactly where this line would be. So I'm just saying solve the equation of this line right here. And then this number right here solves the equation of the line right here. And this mathematical difference is constant between them. There is a constant mathematical difference between these two things right here. And I'm going to try one last thing, and my head will explode if this works. Not literally, but there's no way this works. If this works, amazing things will happen. This is way too much. So it did store it, it looks like. Impossible. No, it doesn't like it. Yeah, don't worry about that. Is this making sense right here in interpret one of the indicator variables? You should get indicator variables. What do indicator variables look like? Indicator variables are not that. Indicator variables are the following. The indicator variable here is male. There's only one indicator variable. And if we're interpreting an indicator variable, we are interpreting one of these down here. This is an indicator variable created from a categorical variable. Is this making sense here, Michaela, how we know what the indicator variable is? It's appended onto a categorical X, as in the variable here is gender. The indicator variable is male. The reference level is gender female. Is this all making sense right here? See, double check with everybody. Intercept interpretation. Be very careful because the reference level does come into play right here. So when you're interpreting the intercept, we're talking about among individuals who are female who have a weight of 0. Two individuals that are otherwise identical, where one is a female and the other is a male. The male is expected to be, boom. William just got everyone 50 points right there. That's exactly it. And if this was on the test, nice job, William. That's exactly a great answer in the chat. Two individuals who are otherwise identical, where one is female and the other is male. The individual who's male is expected to be 5.2, and make sure to throw inches on there. I'd accept it on the test. I'd be like, yeah, you know what you're talking about. 5.0 inches, 2 inches taller than the female, or 5.025. But then the intercept, where I'm probably going to see mistakes, is the intercept is the value for the female reference line. Does that make sense? Like when you think about where the intercept would be, I wish we could extend this graphic backwards a little bit. I don't think Petrie has in his code for visualized model a setting for the X and Y limbs. CEX, that's point expansion. Midline. I don't think he has an argument for the X and Y limbs, which is a bummer. I'd literally have to go through here and recode it. I need to update his codes. It's called the crazy idea. No. It's just that Petrie wrote all this. I will not take that. You should see Petrie code. Dude, do you think I code fast? Holy mackerel, Petrie is super fast. And he knows way more functions than I do. And he also has more of a background in computer science a little bit. He's been using R for like probably since like 2008 or so, like the aughts. Petrie's awesome. There's always someone better than you. Petrie's way better than me. I'm not gonna let that stand in chat. So yeah, no, Petrie's got me. I mean, Petrie wrote this. I've never written a function of anywhere near like this. Petrie wrote this, and this is not even his biggest of functions. Look at the associate function. Petrie wrote this function right here. I just manipulate Petrie's functions. So if I'm manipulating what he's using, what he creates, then he's the one who's the master, and I'm the student. Here's the X lim. So it's getting the range of the X's, okay, and that'll be a vector. Okay, so I'm just gonna tell it what I want. Okay, where's my plots at? 0 to 300. Cool. Sorry about that. Had to sneeze, everyone. Okay. I've hard coded in what I want. I guess I could have taken the second value of the range, and that would always go to 0. That's interesting. I could also have it that you could input that as an argument. So a lot of, I don't know. I got to sneeze so much, everybody. So yeah, Viz 2. Okay. That's a do track error. Okay, we're good. Whoa. It's not storing. Oh, that would be why. That would be why. See, I don't know what I'm doing. Cool. Okay. Let's go back here. Viz 2 of my model. And it doesn't do what I wanted. Let's go back. Look. Lim. Oh, here it is. This is probably where it's at. The Y. No, they want the X lim. XLim range. Here, would I do that YLim? 0 to 300. Evaluate. Okay. What? Do what I want. Ask more questions if you have them. I'm just having fun right here. Like, you might, like, is this fun? Yeah, I'm having fun. Trying to fix code. I like it. What? Okay, here we go. XLim, plot range. No. Oh. XLim. This. Let's just type XLim and search for XLim more. XLim, plot range. Stop doing that. These are not the right things. Intercept interpretation. So the intercept interpretation, and that's actually what I'm trying to show right now visually. Options of XLims greater than 0. Xplot. Wait. You're just going to get all the numbers right here. I'm probably just breaking this. Can you repeat the intercept? Yep. That's what I'm going to do right here. And I'm hoping to show it visually. That's kind of my goal right now. I'm just going to break the code probably. I've changed so much. This is what you don't want to do if you're working with code, is make 30 changes. We're nearing the end of it. Sequence from 0 to 300. And what I really want to show right here, and so if this doesn't work, okay, I think we've changed all the XLims around. XLim, no, stop that. XLim is this. Okay. If I broke it, I broke it. Evaluate code. Find out if we broke it. And the answer is, there we go. And you can't even see where it's down there. Got to change the YLims now. So what I'm trying to show, what I wanted to show, is that the intercept is down here somewhere. And I wish it would plot the lines to that. So when we're making the model, normally we have 2 quantitative variables, but I only need one. No, only one quant, only one cat. Only one quant, only one cat trace. Does everyone notice if here, I can draw this now. I'll use what is on the screen to create what I want. Because this is close enough to where I can show you what's going on right here. Only one quant, only one cat. Okay. So when we talk about the intercept right here, and this is the important thing because we need to see it, not just like say it. If you extend this line further back down here, where do you think that line about hits? Where does that black line about hit? If you extend that black line down further, where about does that black line hit? And this is the interpretation of the intercept and why it's important to understand what we're doing if we see an intercept in this model. Where does that black line about hit? That black line about hits where? And we'll see this again in the output in a moment. Just give me a rounded off number, just a guesstimate of it. Where do you think that black line about hits? And I'm giving you some tips by doing that right there. About 60. Excellent work right there. And the red line hits about where? The red line hits whereabouts. That hits at about 60. And the red line hits about where? And these are for individuals who have a weight of 0, which is an extrapolation of the model, hence why the model is not plotting it. I wanted the model plot to there so you could see it. I have to change YLims also. But the red line hits about where? What does the red line hit about? So, gender male. That says gender male. 65, exactly. Which makes the coefficient, or the estimate of the coefficient, to be 5. Does that make sense? Because those are the difference. And then let's look at the output and see if we see that. Because when you notice where your summary shows, where's my summary? Where the intercept is at 60.3. Remember, we just saw that, 60. And then if you were to add to it 5, you would get to 65. And that's what we're seeing right here at 65. And that's the difference between the male and female predictions for individuals who have a weight of 0. And that's always constant. That's why that's the interpretation. But the thing to know about the intercept, which really hones in on Michaela's question, is that when you see this value of the intercept, this intercept is for the what? This is for blanks who have a weight of 0, which is the what level. This is where I feel people are going to make mistakes on this, because if you're saying everything is set to 0, you have to set gender male equal to 0, which means what right here? Yep. You're seeing it, William. Does that make sense? Because when you set everything equal to 0, you need to make it clear. Well, you're not saying someone's gender male is 0. You're saying they are not gender male, which in this model is female. So I think you're seeing it, Michaela. Does that make sense? So the intercept is for the reference line, which is for individuals who are female. So, and it's just arbitrary because females are first alphabetical before males. So is this making sense how to interpret what the intercept means here? So you are setting gender male equal to 0. It's still when everything's equal to 0, but you need to be specific about it because you're not saying someone has 0 gender male. Send it to me on Discord. Can you Discord it to me? Or send me a screenshot of your screen with your model, and then I'll be like, you got it. Send it to me on Discord with a screenshot of your model, because I'll probably need to see the model. I'll need to see the output. I don't want to tell you you're right. If you're on Discord, you can easily just send me a quick just Discord message, or you can say I sent it via email, and I can look on email and I'll check that out. I think that does a lot for number 2. We'll go back here. Go back. Alrighty, nice job. Great job, Michaela. I just don't want to okay it, because depending on which reference level or things like that, I think people know why you don't see the reference level in the model, because it's the reference level and only indicators receive coefficients. The reference level is when all the indicators are equal to 0. Just make sure your knowledge of this is very clear. If you're like, we just don't include it, try to be clear, try to do full sentences. Pretend these are test questions. Just try to be clear in your understanding of why we don't see the reference level in our model. Like, you don't see it. As in, I do not see an indicator variable for gender male, and that's because there's always one reference level. It's always there. We'll do a break in the video right here. Awesome stuff. Great stuff, everybody. Keep asking those questions. Who has questions? Who has questions? The music's so loud. Make sure Stat1's doing all right now. Look at my emails. Zaxby's sending me emails. What's the easiest way to enjoy Zaxby's? I do not know. With convenient, contactless delivery for our partners. Oh. They're trying to make me order some Zaxby's. No. Can't do that. It's too good. I'll get addicted. What is your favorite fast food? Sadly, mine is probably Taco Bell. Everyone knows. I think William knows I love some Taco Bell. William likes Taco Bell too, I think. Ask any questions you have about the assignment or what's going on. Let's keep an eye on emails right now, but send me those questions. Take a look right here. Good stuff. I'm just bouncing around between different things. Office hours. Hey, I'll like it too. Someone already liked the video. Thank you for that like. I'm still confused about the intercept interpretation. So here we'll go back. We'll talk about intercept a little bit more. So here we'll go back. 2 seconds. Let's do it. Where's my button at? So when you set gender male equal to 0, what are you doing? So let's write the equation right here, which is not required at this point, but let's write the equation. You're predicting, my model's predicting someone's height. You can see it over there in the corner. So we're predicting someone's height. With predicting someone's height, you literally just take the intercept, which is what we're interested in talking about, plus this coefficient. I'm going to reduce these down a little bit so we can put them all on the screen at one time. Sure, we'll just go to 2 decimals. And then you take the variable name and multiply it by the variable name. And we've almost completed writing out our model. Let's annotate a decimal on that. And here we are. Now, the important thing to know is the variable is not gender male. 4A, you got it, Ivan. Let's do that next. The variable is not gender male. Now, if that's the check regression, I made a mistake. I thought I was thinking about logistic when I wrote the check regression. The variable here is not gender male. Why is it called gender male? Well, gender is the variable name. You can see that right here where gender is. And then male is the indicator. So in essence, we are setting these to 0 when we do the intercept. We are setting this here to 0, and we are setting weight here to 0. But the important thing to know is by setting gender male equal to 0, we're actually talking about a what? A who, I should say, not a. But we're talking about a who. What are we talking about? By setting gender male equal to 0, so you get the following equation right here, not that one, but you get this equation right here where you set gender male equal to 0. We've also set height equal to 0, which is now just the intercept. We are talking about females. Exactly. Because the way this model was constructed, we have either male or female, and down here is the female line. So what we did was we showed, visually speaking, that if you extend these lines backwards, you can see where the female intercept is. The female intercept is about at 60. That's just an estimate. And take a look. Reducing this equation gets you what? If you reduce this equation, what do you get? You get about 60. That intercept in the output right here, this value of the intercept, is where the female line hits for females that have a weight equal to 0, which is ridiculous, of course, extrapolation of the model. But that is what the value of the intercept means. It is the predicted value among individuals who are female who have a weight equal to 0. Now, you could get the male intercept line, which is not the current one shown. I'm more confused about the wording. The wording right here would be the predicted value among females with a weight of 0 would be 60.38 inches. The predicted value among individuals who are female with a weight of 0, make sure to include female there because important, you're plugging in the 0 for gender male. You're plugging in the 0 for gender male, which means in this model right here, someone is female. And you're also plugging in 0 for weight, so it's the intercept for the female line, and that's what we're seeing right here. Now, you can get the intercept for the male line, which is not currently shown in the output. To get the intercept for the male line, you need to take, well, it's here in the output, you need to take and put gender male equal to 1, which means the indicator variable is now on, and then you need to plug in 0, because that's going to be the intercept. That's going to be where this red line hits. And then we're just going to add these numbers, and you'll notice what we get when we add these numbers is basically 65. So this number now is the intercept or the expected height. That is the expected height among males that have a weight equal to 0, and that's what we're seeing back here with the red line. And this constant difference of 5 is the interpretation of two individuals who are otherwise identical, i.e. the same weight, would where one is male and the other is female, the male would be expected to be 5 inches taller. You can switch the position of the reference and the indicator. You just have to make it clear which way it goes. Like I did actually switch. Usually I do reference first, like where one is female and the other is male. The person who is male is expected to be 5 inches taller. I wouldn't say females are expected to be 5 inches shorter. That's accurate. But the reason I would say 5 inches taller for males is because males are the indicator variable. It's not wrong to say it the other way. It's a positive coefficient, so we'll talk about it in a positive sense. It's just the numeric value. But yeah, I think Ivan wants 4A, and I think Michaela just sent me this stuff. Let me hop over here. Put on the music. Hopping back. Let's go take a look. Here we go. Michaela's sent me the work. I see here a coefficient smoker. Good stuff. 2 bills that otherwise don't, or 1 bill is. Great job. Your slope looks correct, Michaela. Excellent work. Yep. And then let me look at your other one. For bills for. Yep. Great job, Michaela. All that looks accurate. Michaela, another 20 points goes out to Michaela and everyone. Everything looks accurate right there. Quick, concise on the final point right there. Very clear. How's it all feeling right now? We're going to go over to some 4A here in a second. But Michaela, that was all accurate. You're welcome. Thank you for sending it. It's just so great on Discord, like how you can just instant message. Let me say, yay! It's just so easy to, I don't know. I love Discord. Easy to just send a message and be like, hey, is this right? And then you don't got to worry about like, it's just like instant messaging. Enter, and then you just send it to someone. It's a lot quicker than email. Email's quick too, but I don't know. It's just easier. It's easier. What do we got? Let's take a look at that 4A. Okay, I need to take my same model and make some interactions. Let's go take a look at this. I need to change 3 around a little bit because it's our classic checks. You'll see more about the 2 checks with logistic. My brain broke last night. Explain what the coefficient of indicator variables change in a model without interactions. Oh yeah. Create an interaction between your categorical variable and quantitative variable. Create the summary. Okay, so what do indicator variables change without interactions? This is something we'll be covering tomorrow, so really good talk right here. What do indicator variables change without interactions? You can see it. You can visually see it right here. Like as in, I actually am showing you by going over here to this and showing it. Really? There we go. That's the answer. That's what is changing. I mean, it's changing it throughout the whole thing, but specifically if we were to solve, we can say there's a constant change to this. You see it at the start and it keeps the same because they're parallel. Important to know that there's no interaction right here. We might see an interaction coming up. Let's go ahead and throw in that interaction. Oh, this is theoretical questions. Oh, you got this. You got this. Then I threw in interactions, right? This is from class today. Did I not throw in interactions? Did I dream that I threw in interactions? I don't think I'll answer 4B. I'm not going to answer this one. I answered this like 3 times in class today because it was on the assignment. So I'm not going to directly answer that one, but I want you to watch class. The answer's in the slides. Definitely there. You should know instantaneously how reference levels are created and how indicator variables are created and how many we create. Did I not do the interaction on this? Am I losing my mind? Oh, man. Oh, here it is. Here it is. Oh, no, this is 4. Yeah, so yeah. This is, I think, Ivan, this is what you're talking about. Create an interaction between your categorical variable and your quantitative variable. There was one question I forgot to add. Create the summary. We can't edit it now. Let's go ahead and create our model with our interaction. We should know how to interpret interactions. Hint, that's the question I should have wrote. So explain how it does this without the interaction. Then I meant to write interpret your interaction. Okay. So all I do is put a star between this. This will carry through model hierarchy, which means we will have weight, gender, interaction, and we will also have weight and gender as variables. So let's go ahead and visualize this. And here's the thing. This right now has no interaction. This has an interaction. Oh, look at that p-value of the interaction. Oh, look at that p-value on the interaction. Oh, no. What do you notice about the lines? And I guess I should do it with the same exact thing. Wow. Man. Yeah, what do you notice about it's virtually impossible to see. Because my interaction is what? My interaction. Wait, is that the interaction? No way. Oh, gender has a p-value. It's talking the gender p-value. My interaction has a p-value that is very, very what? And what do you notice about the lines? I'll try to make a better interaction here in a moment. But the lines themselves look very, very what? Because the p-value for the interaction is very this, something we talked about yesterday. So this is how we visualize an interaction right here. This is an interaction. Even if someone said, no, that's not, I'd be like, yes. It's just that it's very, very not statistically significant, which means the lines are going to be more parallel. Probably this is not your assignment right now. Now we're seeing a stronger interaction. I want to get an interaction, though. Stronger. Notice here, and I'll show you the other one. Notice this has a high p-value, and the lines are pretty parallel. And here the p-value got lower, not statistically significant yet. Let's change the model. Now it's statistically significant. Now it's statistically significant. And that's statistically significant too. Cool. So now we're seeing the impact of interactions where we have weak interactions, moderate interactions, stronger and very strong interactions right here. Once again, the stronger the interaction, and I kind of did it in order, funny enough, very weak will be more parallel. If it's perfectly parallel, it would have a p-value of 1 down here. Mine was not perfectly parallel, but was kind of like almost very parallel. This one's getting towards some sort of significance. You can't just visualize it and tell the significance. You need to look at the p-value over here because amount of sample size and uncertainty, i.e. standard errors, are going to come into play. This was actually, I think, the strongest, so you can't always be like, oh, these lines look more perpendicular. There's other important factors like sample size and standard errors that come into play. So it almost goes in order from weakest to almost significant to very significant to also very significant. Technically, this one is the strongest, even though you might say, well, these look more perpendicular. It would probably go to the limit of vertical scatter within these, which will create a smaller standard error, i.e. this has more root mean square error, to go back to previous topics, which will create more uncertainty in the estimates of the interaction. So with this in mind right here, it's important to know this. Let's take a look at this model we just created, because this stuff like this will be on the test. It's not quite on this assignment. When you have the interaction right here, I want you to look at this model. We are predicting somebody's weight. So somebody's height. Which of these is somebody's height more significant in predicting their weight? Which is actually an interesting social commentary almost. Which of these individuals, a male or female, is their height more significant in predicting their weight? I just find this to be very interesting. And the male model really has extrapolations. We don't have any males who are, we only have like one male down here. So I wish we should limit this. I should maybe talk to PTL, we should limit it. For me, are we just doing p-value checks? Yeah, I need to change it. It's just the classic old diagnostic plots. It's classic. I'll send out an update probably too on and be like, hey, number 3 is just your classic. Your classic. So I talked about it like logistically, like for the logistic regression. There's 2 checks in logistic. Male model. So male is more statistically significant. The male line is steeper and has a stronger relationship with height. So Trace, you are correct. It's not quite like better. It's just that height is more significant in predicting the weight of a male than height is for predicting the weight of a female. Females have less variation in their weights, where male height causes more not causes, bad word right there, helps explain male height, helps explain or is highly associated with the weight of a male. Like when you take a male who is like here, 5'10" versus a male who's like 6 feet, you're going to see a greater difference among those males versus a female who is 5'10" and a female who is 6 feet. So there's greater differences. Does that make sense? So here we don't only see a change in the intercepts of the lines because of the categorical variable. We also see a change in the what of the lines. And I'm going to write the implicit regression equations, which we'll cover this too tomorrow. Here we don't just see a difference in the intercepts of the lines. We also see a difference in the whats of the lines, because there's 2 components of a line. The slope of the lines, yep. And the difference in the slopes is caused by the strength of the what. The difference in the slope, which here's a very weak one, here's a moderate, here's stronger and strong also. The difference in the slopes is caused by, or is mathematically calculated by, the what that we included here. Because if we have like none of it, which is this one right here, or we have a weak one. If I have an NA for one of my p-values checks, do I have to go down? Yep. The differences in the slopes is due to the interaction variable. The interaction variable is where we see individuals who are males here have a stronger relationship with predicting their weight from their height. And I think that's the model we're using, yep. So if you want to write out this equation, we have to go here and we just do our classic. This is all we're doing. We're just doing what we usually do. This is not part of this, but I'm just going to do it. We go intercept. We are predicting somebody's weight. So we go here to weight equals intercept plus this times this. I hate that it does that. Plus minus this times gender male. And then here's the interaction term. And there we go. So this is the line itself. This is the equation, the full equation. So there's the full equation. Everything written out fully for us to see right here, full equation. But what we need to do, and we could change that to a star, because it's just being multiplied. What we need to do here is we need to take, and the interaction is positive. I didn't add the positive to it. There we go. What we need to do to solve for the male line is we need to simply go right here and plug in 0 for male. Now just look at this. It's going to reduce. So if you want to solve for the male line right here, you're just going to plug in 0 for male. Oh no, what am I doing? I'm solving for the female line if I do this. This is the female line. Female line, well, 0 times this is 0 times this is 0. 0 times this. And all we do is just cancel this out because they're all zeros. And that is the equation you see over here for the female line. So this female line right here is built from this equation right here on the screen. The male equation, we need to plug in 1. I misspoke. The male equation, you plug in 1 right here for wherever you see gender male. So we go right here and we go to gender male and we plug in 1. And then we plug in 1 here for gender male. And yeah, now we're just going to take this and subtract this from the intercept. You say negative intercept. Well, it's out of bounds, extrapolation of the model. So the intercept right here is going to be this, negative this value right here. There we go. And then the height right here is going to be this plus this. And there we go. And here we go. That's got it. And if you look at the male line, you should see right here that it's going down further. The male line would actually go negative eventually when it reaches 0 because it's at like 55 right here. But this is the equation for the male line right here, negative 490.552 plus the stronger slope. If you compare the female slope to the male slope, here's the female line and here's the male line. So we could put here like female weight and we could put here male weight. And we get 2 separate lines. 2 separate intercepts based on, in part, due to the indicator variables, but also the slopes are drastically changing where the intercepts hit, and the slope is due to the interaction term we see up here. We have to expand this for us to see the full equation. So there's the interaction term right there. Is this making sense, Trace? This is tomorrow's lecture. We'll also start logistic tomorrow, but do you see how we're getting the 2 separate lines right here where I'm just going through and solving the equation by plugging in for males and for male line and female line, I'm plugging in 0 for male if they're male, 1 for male if they're male, and 0 for male if they're female. So many just flip-flop words. But hopefully this is making sense right here when you write the equation and put in the values. Like people should be able to write this equation, and then you should know that the indicator variables only take on the values of 0s or 1s. That's got it. Let's head back to space. Okay. What questions are there? Awesome. For question number 5, we use our original regression model, not the one with the interaction of the x variable. Let me take a look. Write out. Oh, yeah. Here we go. This is just what we're doing. Yeah, let's take a look. So we were just doing some of this right here a moment ago. Write out the implicit line for when your quantitative variable is equal to 0. Correct. So we were just doing this a moment ago. Now, if you want your quantitative variable equal to 0, think about what you're going to be doing. Your quantitative variable equal to 0 is going to be when you go in here and you just set your quantitative variable equal to 0 and you solve the equation. So that's going to be at a certain level right there, and you could get 2 different levels. Then this is me just solving this equation, but you need to take, and let's show it again. I've got a totally different equation right here. And here's my, really? What? There we go. I don't know why the output's being so crazy today. So when you get this output right here, here's the output. To write a regression equation, I've got an interaction in mind. All you do is you go. We are predicting weight. You can see it behind my head right here. Weight is what I'm predicting in my model. You can see it right here. Weight is what I'm predicting. So I'm predicting the value of people's weights. Weight equals $$ turns you into law tech coding, allows you to do equations. You go right here, you go this plus this. Just look, I'm algorithmically going through, going this plus this times this plus this times this plus this times this. You just go through and algorithmically do it, and you make it look nice and neat afterwards. So all you're doing is just grabbing these values and just putting them right here and then multiplying by them by what they're next to. So we just go ahead and we grab this also. Come on. You can do it, little guy. And then plus this right here. Times this. Awesome. That's got it. There we go. That is a model. And if we want to set something equal to 0, we can just go in here. We can say the individual here is male, and we would set that equal to 1 if we're saying individual is male. In my model, the quantitative variable is through an interaction, so you'll be using your non-interaction variable right here. But you can set the height equal to 0. I'd also need to set it equal to 0 here. Make sure to reduce, as in if I wanted to reduce this through, well, then this is going to go away. I'm going to destroy my model if I do this. I want to keep it so I can have it. Show your work like I'm showing right here. If you're setting something equal to 0, you're just going to set this equal to 0. Well, this will 0 out right here. Let's watch it right here. You can just see what's happening. This thing right here represents a multiply. That is just how R shows it. It just represents multiplying by. So here we are with the value of 2.66 times 0 times gender male. Gender male is whether or not someone is male or not male. That is 0 because something times 0 is 0. Without the interaction. I wouldn't take out points if you use it with the interaction. And right here, this is for individuals who have a height equal to 0. For question number 3, how can I take a look at my categorical NA to see if it passes No linearity for it. No linearity for it. Because it just doesn't, we don't do linearity for it. I would not use, for this, I would not use the interaction right here. I say don't. I use the interaction one. Yeah, you could do the interaction one. Either or, I didn't specify. So I'm basically showing how to do it right there. I think it's good right there. Keep asking those questions. I think, sounds like people are pretty far in this one. I need to make these harder. I need to make like daily assignments. I feel like no. Yeah, it just can't be done for categorical variables. It's just, there's no linear relationship because it's just a difference in the intercepts. I think when you look at the plots, it'll actually show you a plot. Here, I'll go look at the plots right now. When you do the plots, you'll get like dots like this because it'll do the 0-1 separation. And then it'll give you an error saying it can't do it. Oh, I'm not in an R chunk. What was it? Oh, we'll hop back to that here, Michaela. You got it after this one. Okay. And there's our plot. If I'm to guess what the p-value is on, normality is going to fail. That's obvious. Linearity is going to be a little bit low. Equal spread probably passes. Equal spread's the highest. Everything else fails. Equal spread is failure. Outlier looks to be an issue. Normality of residuals is a major issue. Linearity maybe something. But my big issue here is the normality of residuals and also the outlier. Some linearity. I don't really see the equal spread, but everything fails. Everything fails. We can't do a check on gender. Also, the linearity of height fails too. Let's look at the linearity of height though, see if it causes an issue. I threw in the extra argument right here, extra equals true. That's going to allow me to look at the linearity of height. And I mean, that's where the main form of the relationship is coming from. There is some sort of non-linearity in here because I can see a bend right there. The line doesn't look to be slicing through the middle of the data. Gender male comes up with the points I said it would. It just, you don't look at the there's no linearity of that to check. And this is also my interaction. I don't, did it give me a p-value on that? Oh, it did. It did. Said it failed. Apparently that fails too. Definitely, definitely, yeah. So, yeah, just you can't really look at this. It just can't compute it because the way it works right here, it just doesn't have enough unique values along the x, and it just literally tells you that with the two-level categorical variable. So yeah, can't do it right there. And this one, it's got problems. This one's got a good bit of problems. 4a. What was 4a again? 4a. Explain why the coefficient. Yes. Ah. Let's go back. What do coefficients change in these models? What do the coefficient of indicator variables without interactions change? There's a constant change to the model, which actually, when we look at the equations for them, change what? What do indicator variables change as we look at models right here where we have, this is my model, and this is the answer on the screen to what this coefficient, and I guess I should technically put it over here. If you look exactly where I'm putting that, what is this coefficient of the interaction truly changing equation-wise? Maybe I think you should be able to see it if I could just click away. Click away. I can't click away. Wow, that's amazing. Really? There we go. Does it make sense here what it's changing? Hence where I put the green line. It's a constant change of this value, which could be seen when we look at this value. Basically, the blanks of this are all changing. I don't want to say it, but I want you to kind of think about it and look at this graphically to be like, oh, there's no interaction right here. Maybe delete trace. I want people to think about it. And I want people to I see it. It's a constant change of the model because the lines are parallel, which means they have the same this. I think you guys are getting it. I think you guys are getting it. So that's, when you look at it mathematically and everything, that's what's going on right there. Does that make sense? Like there's a constant change when you look at the two lines. They just have different thises. That's an important thing to know. And the difference between it, the bigger it is, the more it is. We'll go back here. We'll do trace question. Nope. If it has an interaction, with an interaction, it will change the slope. So here's a model with no interaction, and here's a model. So there's no interaction, and here's a model with an interaction. Does that make sense here? No interaction, interaction, no interaction, interaction. Look at me, look at you. Look at me, now look at you. So here's the no interaction model, and here's the interaction model. The interaction model, which does have a statistically significant interaction, allows for a change. Thank you guys, both of you 50 points. Thank you so much for helping out right there. I always want people thinking through these things and looking at the graphics and seeing it. It's one thing that, that's the thing. And it's one thing to just hear something to be like, it changes the intercept if there's no interaction. I'm just literally saying the answer. And you can see it right here visually. And then if you start thinking that and being like, oh, it's a change to the intercept, and you can also see it here mathematically, like if I do the non-interaction model, then all that's going to happen if we have somebody who is gender male, then all that's going to happen is the intercept is going to increase by this value. So we just take this, and technically since it's a positive, we would add it. And the new intercept, I don't know how my brain works. The new intercept for the male line, something's off. Yeah, no, that's correct. The male line is higher. So the new intercept for the male line is going to be 35.41, and it's going to be negative technically. So a little bit crazy right there. But the male intercept, because remember, all you're doing is plugging in a 1 here for male, and then that becomes 23 plus negative 59.17, because the female intercept is going to go way down here to negative 59, and then the male intercept is going to be, as you can see, 23 higher. If you look at the units right here, this is about at 100, and that's about at like 123 or so. That's maybe 98 and 123 or 120. I can't do math. But is this making sense here? I think this answers both questions right here. But to Trace's and Mikhail's question, is this making sense right here? So if we do an interaction, it'll change the slope. And that's what we're going to talk a bit about tomorrow. Is you can see right here, the interaction now is where we see the difference in the slopes is 2.65. So the male line is more sloped. This value of height right here is actually the slope of the female line. The female line is very easy to read because you just put gender male equals 0 and gender male equals 0 right here. And then the female line is just the following equation of the height and the intercept. So the height and the intercept are the height and the intercept of the female line. But the male line is more sloped. Here's the more sloped by that much. Also, it has a lower intercept by that much. They're going to really diverge here later on. So the male intercept is negative 159.04 lower, and the male slope is, so you would lower the intercept, and you would also raise the slope by 2.65. Is this making sense? I think Trey's saying it making sense right here. If you're getting this, you are prepared for tomorrow to be like, oh, we just plug in, it's an indicator variable, so you plug in 1 or 0, and then you just solve through. Like here, I'll take this and screenshot it here, and we can see all we're doing with this stuff right here is though I say the person we're making predictions on is male. Well, then you go here, and you say, okay, they're male, right, Brian? Tell me they're male. So I'm going to go right here, and for this individual, since they are male, I am just going to plug in 1. Let's do a big 1 right here. 1 and 1. Well, this is a constant value right here, so it would get added to the intercept. The intercept's going to be very negative. And this right here has the same x value, so these two get added together. So you can literally tell it's going to be like, so the weight of males, we're predicting weight, is equal to about negative 150. And I'm just adding together two numbers in yellow right there. I'm just doing a quick add on it. It's not perfect. And then also plus, and then that's 4.5 about. 4.5 height, because we're combining like terms. And that is the equation for the male line, about, not solving exactly. So in the revision part of the homework, when we get an A, yeah, you just can't check it. You could say that. Just can't check it. It doesn't check. Can't check it. Does not apply. Good answer right there, Michaela. Now, if you want to solve for female, you're just going to go in here. And for gender male, you're going to plug in 0. Well, this makes this the easiest line ever to write because 0 times this is 0. 0 times this is 0. 0 times this is 0. So you're literally just going to... These are going to go away. So the equation for the female line, so this is male weight, and female weight has the equation of 9.52, which is the original intercept, plus 1.95 height. And I'm literally just taking the original values as they are. And you can see here it has a different slope due to the interaction and has a different intercept due to the indicator variables. Hopefully this is making sense right here, seeing as I go through and solve this output by merely plugging in 0s or 1s, depending on someone if it's gender male or not gender male. I think it's got it. Great answers, everybody. Great stuff. Yes. Good work. Well, I think that's got it. How far are people in the assignment? Trace, Michaela, are you done with the assignment? I mean, we just put it out this morning, like at 1 a.m. I think people are finishing up the assignment as we speak, which is good news. I need to make them more difficult. More questions. Basically, John, just a few tweaks left to do. Great job. Get the activity done today, the assignment done today. Great stuff. I'm really hoping class is like, when you're in class and then you look at the assignment, you're like, wait, this is exactly what we did. Exactly what we're talking about. These concepts I want to be carrying over. And that's what I'm focusing in on. Basically, I'm writing new assignments right now to make sure like it's exactly what you're hearing in class. Because I'm like, okay, what am I going to be talking about tomorrow? So I'm sorry that the assignments come out and then like you get 2 days. I don't think that's too crazy. It's the summer. The class is 4 weeks. So I mean, I'm giving you like 5% of the class to do it. I don't know. But I look at what we're doing and then like saying, okay, I want us to have exactly this. Because I think there was one assignment where I put a ton of bonus on it. I was like, I don't know. I didn't think we covered those concepts well enough then. So I'm like, okay, we're going to cover this. Well, if you get stuck, if you have questions, let me know. I will be back tomorrow. It's Friday tomorrow. Until then, I'll see everyone later. Bye for now, everyone. Bye.